Okay, we're back for part two. Here's a question about proportion above its mean and to the largest proportion of data below its mean. Smallest proportion above its mean to largest proportion above its mean. So again, we got to think when we're skewed, that basic rule of thumb, the skewness pulls the mean towards it. And so if the skewness pulls the mean towards it, where would there be more data points above the mean? Where would there be more? So the mean's probably right here, close, because that's symmetric. So it's going to be, hopefully you're going to figure out, it's going to be somewhere between here and here. And you got to figure out which one. This is one of their favorites where they have you compare box and whisker plots. Again, look at the outliers. If you're doing range, you're going to use this. It's not from here to here. That's not the range. Your range is going to be from here to here. That's one of the tricks they try to do. You go, oh, look, that has the smallest range. No, that has the biggest range because there's this outlier here. And that's another reason why we sometimes use interquartile range, because the range for this one doesn't really tell the tale. The data points are bunched together, except for this one that's way out there. But here, we're going to just be looking at the scores. Here's my 25% of the data is to the left of this. 50% of the data is to the left of this. Is 50% of the data higher than all of the data? See, this 50 is higher than all of that. Is this 25% or this 75% going this way higher than all of that? So you're going to have to kind of split up. What they like to do is they say, here's 25% lower, and then they'll say something like, 75% of the data of section 2 is higher than section 1. And definitely 75%, almost all of it. We can't really tell because we have these two outliers. But you just have to break down your box plot. 25% this way, 75% that way, min, max, 50% to either side of this, and compare them. Make sure you really read everything and get an idea for that one. Here's my stem and leaf back to back. We just looked at this other day. We looked at the key. You may not have seen a back-to-back stem and leaf plot. All this means is that for the males, I got no 6s. I got a 72. I got an 81. I got a 90. So I'm looking kind of this way. And then for the females, I got a 64. I got a 75 and a 78. I got an 80 and an 89. And as we did before, kind of remember, if we're going this way, that's a negative skew or a skew to the left. If you see a skew going down, we're skewing towards the larger numbers. That's skew to the right or positive skew. And it's just asking what the shape looks like, which he talked about. Here are two distributions. This would be a bimodal, and this looks roughly normal, symmetrical. Maybe not so normal, but symmetrical. They're both symmetrical. And you want to think about where the mean would be and where the median is for symmetric data for these two. Look at the range and what do you suppose the standard deviation is? Remember, the standard deviation tells you how far most of the values are from the middle. So which, if you're talking standard deviation, which one of these has closer values towards the mean, has more values towards the mean, that would be the one with the smaller standard deviation. Here's a box plot that they turned into a histogram. So how do we do? Gotta get on that. Pick your points. You have your min. So hopefully they're all starting at 35. You have your max, which is around 64, 65. Hopefully they're all finishing there. So they are. You can't rule anything out. 25% of the data is between these two. 25% of the data is between these two. 25% of the data is in there, and 25% of the data is in there. Which one shows that? This is your frequency. So look for the same number between here to here in your frequency, between here to here, as between here to here. And you should have the same number between 56 and 60, and the same number of points between 60 and 65, because all those are 25% of the data. So that's what we're looking for that. Over here, now over here, they don't give you a visual display of data, but we can very well make a very quick copy of this. 7, 8, 9, 10, 11, 12. I mean, if you can't see it, some of you might be able to look at this and see where the skew is, or if there is no skew. But if we can't, I need 4. All right, let's say that's 4. This would be 6. This would be 7. This would be 6. This would be 4. And then we got 2, 2. I just made it quick. I don't even have to 1, 1. Just give myself a quick look at the data and then go through which one of these I think it is. So just always, if you can, you don't have to, you can look at that, but sometimes it's just a lot easier if you give yourself a visual. There's a lot of questions. I'm not going to get through this. Well, we do have a 4-day weekend. While everybody else is outside having fun, or maybe went out last night, or I don't know, working or something, you guys are going to be inside getting your work done. Here's another thing. Oh, this is a key one. This is a great one they like to ask about box plots. They ask you about the number of things that are going on in the box plot, the number of data points. So my first question, if we read this, data were collected on the number of text messages sent by each student in a large high school for one day, and here's the box plot. How many students did they talk to? We can't tell how many students they talked to. But here it's trying to ask you questions about how many students. There are more students with data values below the median. How do I know if there's more students below the median than there are with data values above the median? I don't know how many there are. The only thing I know is at the median, 50% of the students are to the left and 50% of the students are to the right. So if 50%, would there be more to the left than there is to the right if there's 50% on each side? So all these things, there are fewer students with data values between the first quartile and the median than between the median and the third. Well, think percentages, don't think numbers. They try to throw you off with saying there are more because this looks bigger. This just means the range of text messages sent for these 25% of students is bigger than the range of the text messages sent for these 25. That doesn't mean there's more students in this 25% than there are in that. They're both 25% of the students. So think about percentages when you're thinking about box plots, not numbers, unless they tell you how many students there actually are. And read through those and figure it out. Here's another one where you're comparing two box plots. This actually tells you there's 20 men and 20 women. So we do know that there's 20 in each. And then it says there are more people between the first and third quartiles for women than there are between the first and third quartiles for men. Same type of question. They're trying to throw you off. Women looks bigger. Oh yeah, look, there must be more. No, first quartile, 25%, third quartile, 75. They both have 50% and they're both 20. So there's 10 in here and there's 10 in here. All right? If there was more women in general, like 24 women, then yes. But since both of them are the same, they have the same number between the two quarters. So you're going to be looking, again, what I would do is go min, quarter one, median, quarter two, max. Do the same thing over here and get an idea of what they're talking about. More than half of the men had lower pulse rates than 3/4 of the women. Well, here's half of the men. Is this lower than 3/4 of the women? Here would be 3/4 of the women. No, it does not look lower than that. So you're just kind of comparing the bars. I keep doing that. Just compare the two places and see what you get. Here you got a segmented bar chart. This is in relative frequency, which means percents. This is 20%, 40%. Once again, we looked at one bag of each brand and counted the number of pieces of each color, but then we're using percentages. So I don't know how much candy's in here. So a great question that you may mess up on is they're gonna say something like, brand Z has more red candies. There's the number of candies of brand Z is more than the number of red candies in brand X. We can't say that because this bag might only have 10 candies in it and this may have 1,000. So although the percentage in brand Z is greater than the percentage in brand X, I can't say the number of candies that are red in brand Z is greater than the number of candies that are red in brand X, because this could be 1,000 candies, this could be 10. See, that's what they're trying to do. There were more green candy pieces. But this is talking about just brand X, so can we say that for just brand X? For brand Y, there are more. Here they're comparing the two. So we can't compare the number of pieces between bags. We can only compare the number of pieces within the bag by looking at the percentages. Here's looking at a histogram. Remember what I told you about the histogram and about how we don't have exact values. So if I'm talking about range, I need a maximum range and I need a minimum range. If I'm talking about median, I need an interval. I don't know exactly where the median is. I can figure out where it kind of is, but it's between two numbers. So in this one, we're not really talking about absolutes, unless we're talking about like a maximum median, maximum range, minimum range, maximum IQR, minimum IQR. Then we can figure that out. Here's a very similar question that we saw from before. It shows you a stem and leaf plot side by side and asks you to talk about the median, range of both of these. How do we find the median and the range? Range is easy. Make sure you know what 7/0 represents. 10, 20, 30, 41, 52, 130, 132, 154. So your range would be 154 minus 20 for this one. Median, we just got to figure out there's 55 bears in each cave. Oh, it's the field. So we got to count how many there are. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, and so forth, and figure out where the median is on this. We've done that. Here again, we're looking at box plots. Notice the first one. The number of brands classified as healthy is greater than the number of brands classified as regular. I'm going to ask you again, do we know how many brands there were? Or do we just know percents? It doesn't tell me how many brands they looked at, so I can't talk about number. Common theme with the box plot questions. You cannot talk about number. Thus ends part 2. Blew your mind.